Hey guys, welcome back. This is going to start week 3, lesson 1 for us. We are discussing real world problems using Trig from last week. If you did not have power last week or you didn't have Wi-Fi, I was in the same boat, and you have not gotten caught up with the week 2 learning, I extended the due date for that stuff to Friday of this coming week, so you'll have plenty of time to cover that. And make sure you're an expert with those lessons before you jump in to learn this material, okay? All right, so our essential question for today is, how can trigonometry be used to solve real world problems, okay? So remember, we use that acronym SOHCAHTOA to remind us what each of the trig ratios represents. So just as a reminder, it'll be a good refresher for us to write down the equations that we have for sine, cosine, and tangent, okay? All right, so just a reminder, the first 3 letters mean that the sine of an angle is equal to the ratio between the opposite and hypotenuse sides, okay? So last week we talked about when we are finding an angle, we can take this equation, reverse the theta with the ratio, and that gives us the equation for inverse sine, which, remember, the little -1 is inverse. So let's write down those equations just to remind us, again, what that acronym stands for, okay? All right, that's sine. Cosine of theta is adjacent over hypotenuse. The inverse cosine of the ratio gives me theta. And then the last one, tangent of an angle, is the ratio for the opposite to the adjacent side. And then the inverse tan, O over A, and the theta flip. Okay, so remember, there's a difference between this top row of equations and the bottom. The top are used to find missing sides, so opposite, adjacent, or hypotenuse. And then we use the inverse equations to find an angle given to side lengths. Okay, so just remember, if you are still not sure on the difference between when we use what, I would go back and watch the week 2 videos again, okay? All right, so with that in mind, we are gonna look at how we use these problems in a context, meaning a real world situation, because that's what we all wanna know, right? With math, how am I ever gonna use this? Okay, so this example says that an 8-foot wire is attached to a broken stop sign to secure it. The wire is attached to a stake and makes a 51-degree angle with the ground. How far from the stake is the base of the stop sign? Okay, so this time I gave you a picture, but in some of the word problems that you'll be looking at, you'll have to draw your own, okay? So here's my stop sign. This wire has been attached to the ground to support the stop sign and keep it upright. If you've ever seen trees planted, freshly planted trees, you'll see a rope or some sort of wire maybe attached to the ground until the root system is broad enough that it can support the tree. So that's what's going on here. And the stake in the ground is just holding the wire in the ground. It's like a little metal pin, okay? Okay, and then we want to know how far from the stake is the base of the stop sign, okay? So we know that the stop sign from this first sentence, we know the wire is 8 feet long. So I can label this part of that right triangle created in this situation as 8 feet, okay? So we also know that the wire is attached to a stake and makes a 51-degree angle with the ground, okay? So with the ground is gonna tell me, if I'm looking at these 2 angles in my triangle, it can't be the top angle because that's not created by the ground, okay? This angle is what that is referring to. So this is my 51 degrees. So make sure, read the problem through, label your information. underline what's important and look at the keywords around the numbers, because that's going to tell you where to label that in your diagram. Okay? So we want to know how far from the stake is the base of the stop sign. So that's referring to where it goes into the ground. So we want to know this length in our triangle. Okay? So just like we did last time, you always start by labeling. So clearly my reference angle is 51 degrees, okay? And then my hypotenuse, the longest side of that triangle, is 8 feet. That's the length of the wire. The opposite side is the length of the stop sign here. And then my adjacent side to 51 degrees is X. Okay? So just like we did last week, when you're solving for a missing side, you think about what information am I given and what letters in the diagram can I use to choose a trig ratio, okay? So we know that our theta is 51 degrees, H is 8, the adjacent side is X, and here we don't know the length of the opposite side, and we're not being asked to find the height of the stop sign, therefore we are not going to use the opposite side. Okay, so think about SOHCAHTOA, which ratio we'll use A and H. Okay, that's cosine. So I'm going to set up my equation. Cosine of theta is equal to the adjacent over the hypotenuse, and then plug in my information. Okay, so cosine of 51 degrees is equal to X over 8. So remember, if the variable, the X in this case, is in the numerator, we need to use an inverse operation to isolate or to get that by itself, okay? So since X is being divided by 8, the opposite would be to multiply both sides by 8, okay? And again, the reason that I do that, when I multiply, that's going to cancel out with the 8 in the denominator, and I have what I want by itself, okay? So we need to grab a calculator or go to Google and figure out what 8 multiplied by the cosine of 51 is. So again, make sure you're in degree mode in the top left-hand corner. 8 cosine of 51 is 5.03. We'll use 2 decimals here since it didn't really ask us. Normally it'll say to the nearest foot, so you could just say 5 feet, but we'll just be specific here and say 5.03 feet, okay? So we're really not doing anything super different than last week. We're just looking at how we use these ratios in a very specific situation and how to label a diagram based off the word problem, okay? All right, let's move on. Okay, so this is a situation where a student is flying a kite. So it says a student lets out 100 feet of string on a kite from a hand height of 3 feet. Okay, so that means that if they're standing up, where they're holding the string, the distance between their hand and the ground is 3 feet. Okay, the angle between the horizontal hand height and the kite is 25 degrees. Find the height of the kite above the ground, okay? So in this, I gave you the diagram here. We have the kite. This is the string from this person's hand. We know that's 100 feet long. The person's hand is 3 feet off the ground. And here where it says the angle between the horizontal hand height, remember that means this way, not that way. And the kite is 25 degrees. So that's referring to that angle there. Okay, so what we need to find is how high this kite is off the ground. So if you notice, there's 2 parts to this problem. we have to find this height, the height from the kite and the hand, and then add on how high the hand is already above the ground, which is 3 feet. So once we find this length here, we're gonna add on 3 to find the complete height off the ground. Okay, so there's two pieces going on here. All right, so again, let's start by labeling. Sorry if I sound a little out of breath. I went on a run right before this and whew, I was struggling. Okay, so let's label. This is my angle. Theta is 25 degrees. My hypotenuse is 100. I'll put this in yellow so we can see. We are trying to find this. Let's call this 8. Let's call it, I was gonna say H for height, but we already used that for hypotenuse. Let's use Y. And then the adjacent side is this length down here that we clearly don't need for this problem, okay? So this is also my opposite side. Hypotenuse here is 100. My opposite side is Y that we are trying to solve for. The adjacent side, don't know, don't need it. Okay? Think to yourself, what trig ratio uses what trig ratio in SOHCAHTOA uses O and H, and that is sine. So sine of theta is equal to opposite over hypotenuse. My angle is 25 degrees. And I have Y over 100. Again, I'm using my inverse operation, which is multiplication, to cancel out and solve for Y. And let's see what 100 times the sine of 25 is. 42.26. Okay, and that is measured in feet. So remember, that's only part of this. That is just this height. We now need to add on 3 to find the height for X. So X is equal to what we just found, plus the additional 3 feet. Okay, so that's gonna give me 45.26 feet. So in these types of questions, you always have to ask yourself, is the height measured from the ground, or is there an additional height that I'll have to add on to find the complete height, which in this case was 3 feet. Okay. All right, so let's move on to example 3. So a ladder is, we don't have a diagram here, so we're gonna have to draw this. So a ladder is leaning up against a wall. So obviously a wall is gonna be up and down. And if the ladder is leaning, it's gonna be at an angle. It's not vertical or horizontal. The ladder is 12 feet long. And the base of the ladder, meaning the bottom part, is 8 feet from the wall. So here's the wall, here's the base. That length is 8 feet. And remember, a wall and the ground make a right angle. Okay? So we want to know what angle is made between the ladder and the ground. Okay? That can't be this angle at the top because this is the ladder and the wall. This angle at the bottom is made by the ground and the ladder. Okay? All right, so let's label. Let's label our reference angle. That's here. Hypotenuse is 12. Opposite, we don't know. That would be the height of the wall. And then the adjacent side is 8. Okay? So clearly here, we can see, since we're given the length of the hypotenuse and the adjacent side, we'll have to use cosine. Okay? So let's skip the part where we've been writing down what's what and see if we can just come up with the equation from our brain. Okay? So I'm using cosine, since I have A and H, not using O. cosine of my angle is equal to 8 over 12. So remember, if you are finding an angle, you have to use inverse cosine, okay? So we are going to rewrite our equation so that my angle is what I'm solving for, okay? So this is going to look like inverse cosine. I'm going to flip these two, equals theta. So this is just a one-step, type it in your calculator. Remember, you have to type in inverse cosine. You'll see the -1 pop up. 8 divided by 12, and that gives me an angle of 48.19 degrees. And then I'm done. So this week we are not going to do IXL practice. I'm actually going to post the second lesson, and then you'll take 2 quizzes at the end of the week over this lesson and then what we do for the next lesson this week, okay? Don't forget about the tutoring sessions on Monday at 11 and Wednesday at 11. If neither of those times work for you, just shoot me a message or email me and we can figure something out.